Hey everybody, my name is Kelvin and welcome back to episode 11 of my Learn Python series. Today, we'll be going over part 2 of object-oriented programming. If you recall from part 1, we introduced objects, classes, instances, attributes, instant methods, things like that. This episode will build on that by showing you how classes behave once you start using them in larger scripts. Things like shared state versus per object state, or how to make objects print cleanly, different kinds of methods you'll see in real code. This episode will build on that and teach you a few more techniques that are crucial to object-oriented programming. If you haven't seen part 1, I strongly recommend it because the concepts in this video will build on what we already covered last time. Also, real quick before we jump in, if you've been enjoying the content on this channel and want to support what I'm building here, check out my book Modern Data, From Ingestion to Production. It's a practical introduction to how data moves through modern systems, from ingestion and transformation all the way to production use. It's available on Amazon, Barnes & Nobles, and Apple Books, and the ebook is only $6, so it's a really affordable way to support the channel and learn something useful at the same time. Be sure to check out the links in the description. Without further ado, let's jump right in. We'll create the folder for our lesson 11 here, lesson 11. And we'll create our first exercise like we usually do, 11-1.py. And in this exercise, I want to cover the difference between instant variables and class variables. In part 1, we used instance variables. If you recall, instant variables are attributes that are stored on a specific object. If you have two person objects, then each person has its own name and their own age. Changing p1.age would not change an object p2's age. Class variables are attributes that are stored on the class itself. Every instance can read them. They're used for things like shared defaults, constants, configuration values, and counters. Let's define a class. We have a class called person, and here we will have two class variables. Again, class variables are shared by all instances. So we have a person class, and we have class variable that we'll call species. And since we're a person, our species, hopefully, is human. And then we'll have count created is equal to 0, because as of right now, we've created no classes of person. We'll define our init constructor like we covered last episode. And in our init, we'll pass in name and age. And here, we'll have an instance variable called name, which is equal to the name parameter that we pass in, and self.age, which is an instance variable that we created to track a person's age. And then now, what if we wanted to update the class level state? What if upon creation of a person class, we wanted to increment count created by 1? We can do that like this. We can do person, which will reference the person class, person.count created plus equals 1. And this, every time a class person is created, will increment count created by 1. And this is shared across all created objects. Let's see it in action. So we'll have a p1 is equal to person, and we'll have it be me, Calvin, and he's, 27. And we'll have a p2, which is equal to a person called Madison, and she'll be 24. And now we'll print p1, p1's name, and p1's age. Do the same thing for p2. And we'll also see the species. And species of myself. Oops. And p2.species. And finally, let's print person.count created. And here, since we've created two objects here, P1 and P2, both being of person classes, we should expect to see that this number right here is 2. Because every time we create a class person, this init constructor runs, and it sets the name and the age, and it also increments the count created in class person by 1. And remember, this is shared by all classes. We'll run this, and we'll see Kelvin 27, Madison 24, 3 humans, which are all of these. Person.species is human, P1 species is therefore human, and P2's species is human, and then count created is 2. And that's what we get. One thing to keep an eye out for is what happens when you assign a class variable through an instance. When you write something like p1.species is equal to alien, Python creates a new instance attribute named species on P1. It doesn't change the class variable. After that, P1 reads its own instance attribute, while other instances still read the class variable. What do I mean here? Let's jump back up here. And we'll set P1 species is equal to alien. We don't need this right now. Since we set P1.species is equal to alien, now this is an instance attribute. And we should see alien. But the person.species would not change. We'll still expect to see a human, because P1.species did not update the class variable. Same thing with P2.species, because it still relies on the class variable. So here, we should see human, alien, and then human. Run this, and that's what we get. Now if we set person.species is equal to robot, notice I'm setting the class variable now. We can do p1.species print p2.species, and then finally we'll print person.species. And now, what should we expect to see? We'll see alien, because p1.species is still alien. Now p2 species is going to be a robot, because now we've set person.species, or the class variable, to robot. And since p2.species references that variable, we should expect to see robot, and of course this will give us robot. And let's run it and see if our hypothesis is correct. And it is. Remember one thing. Use self.x for per object data. Use className.x for shared data that should be consistent across objects. And that's the key principle here. Let's move on to the next exercise. Create a folder called 11-2.py. And here I want to cover a couple more methods that will come in handy when you're working with classes. That being str and repr for clean printing. When you print a custom object without any special methods, Python will print a default object representation that is not useful for understanding what the object contains. In real projects, clean printing matters because you will print objects during debugging, logging, or testing. Python will give us two methods to control this, that being str and repr. Str controls what you see when you call print some object. This is usually a readable summary, while repr controls what you see in debugging contexts, such as printing a list of objects or inspecting objects in a console, and is typically a bit more explicit. Let's pull the person class that we created last time, and we'll use it for this exercise. Since we're not covering class attributes, since we're not covering class variables, we don't need that. We'll have our init, and then we'll create the two objects that we created last time. And now, what if we wanted to print P1 as is? Oops, we need to get rid of this because we no longer have a class attribute. Run this. And this is what we would usually get. This doesn't make a lot of sense to us. What is this? At some address memory? That's not useful for our context. That's what str and repr are supposed to be, or are supposed to be used for. We can define it like this. in a very similar fashion as the init constructor. str, and that'll take itself, colon, and then we can return some human readable version of this object. We're going to define it like this. .name, squiggly bracket, self.age, squiggly bracket. And this is going to be just going to be a string representation of our object here. All we're doing here is doing something like Kelvin, in parentheses, some age. So here, for the string representation of this, is going to be Kelvin, space, parentheses, 27, parentheses. And all that's doing is just formatting your variables in case you want to print this object. Now, let's see what happens when we print Kelvin 27. And that's what the purpose of str is for. Let's create a repr method. And we can define it like underscore underscore, repr underscore underscore. And again, it'll just take itself. And we can return person. Name is equal to self.name. And age is equal to self.age. And this will be our developer or debug version. And what we created here, this exclamation mark and this R, we'll use repr formatting for the string, which is useful in debugging. So now we already have our P2, and we'll just print P1 and P2. And now down here, we can do people is equal to P1, P2, and we can print people. And what happens down here is now we use repr for each element within people. So let's print this. And now down here, you can see that we used the string method for Kelvin and Madison, but down here, we've used the repr method down here. So you can see that there's a different format here. And all this is doing is just giving us a human readable way of seeing our object. A reason why you might use repr style formatting is that it makes special characters visible. For example, what if we had a string s called Kelvin, and then we had a complete new line that we can do like that, and my last name, and then what if we wanted to just print s? This prints with a new line, but what if we wanted to have repr style formatting, and we can pass in s to our repr function, and now we'll see Kelvin /n Lin, even though it's the same string. And what this can help us with is debugging, because what if you didn't know why? What if you didn't know why there was a new line here, and we didn't know what s looked like? Using repr here would tell us, oh, we have a new line here because there's a /n. This can really help when objects appear only inside lists or dictionaries. Let's move on to the next exercise. Create an exercise folder called 11-3.py, and here I want to cover instance, methods, class methods, and static methods. If you remember from part 1, we used instance methods. Instance methods operate on only a specific object, so they take self as the first parameter. They can read and modify instance variables. Class methods operate on the class level. They take CLS as the first parameter and are called on the class. They are often used to provide alternate ways to create objects. Static methods are functions that are placed inside the class for organization. They do not receive self or CLS. They are used when the logic relates the class conceptually, but does not depend on the instance state. Again, let's borrow our person class from up here. We'll jump down here, copy and paste it. But now, let's define an instance method. This is something that we've seen before, and we have birthday. Here, we also want to define another class variable called species. It's equal to human. And this instance method here will take in self, and we'll increment self.age by 1. This instance method only works on one single instance. Now, what if we wanted to define a class level method? We can do that using this notation at class method, and we can have our class method be from birth year, and what it'll do instead of taking itself is the string CLS, or is the variable CLS, and we can pass in name, birth, year, and the current year. And here we can have age is equal to current year is, and minus the birth year. And then we can return CLS, name, and age. And I'll just create the static method before we move on to any more explanations, and we can do it by @static method, and we'll call this def is adult, which takes in an age parameter, and we'll return whether or not age is greater than or equal to 18. And then we'll also have some prints down here, have a person object that has me, and let's say my age is 27 again, p.birthday, print p.age, 2 is equal to person dot, and we'll call our class method here from birth year, and we'll have Madison, and say 2005 is her birth year, and 2026 is when it's now, and then print p2.name and p2.age. And we'll have our static method here, 17. I'll explain all of this very shortly. Let's jump back up here. Here, we're creating a person object called Kelvin, and it has a name, Kelvin, age 27. And what p.birthday here is that Python will call the function with the instance automatically. So within birthday, self is p. When you call person from birth year, Python calls the function with the class automatically. So within that method, CLS is person. Using CLS instead of person keeps the method correct even if you later subclass person. Static methods are basically just like normal functions. Python does not inject any extra first argument, and that's the difference here. Right here is our instance method. This operates on the specific instance. Here is at the class level, and here is static, and this doesn't inject anything before we call the function. Let's run this. And we'll say p1.birthday. We'll get 28 because now we've run that method on the p object. And then p2 right here, we have the from birth year class method. And then person is .adult. It doesn't matter what else we have in our classes and whatnot. All it's going to do is just run a simple check to see whether or not 17 is greater than or equal to 18, which it isn't, and 21, which is. So that explains the false and true down here. And that's the difference between all three. Let's move on to the next exercise. We'll create 11-4.py, and here I want to cover composition. Composition is when one object stores other objects as part of its state. This is a common way to model real programs. A course can store students. An order store line items. A playlist stores songs. Let's create two classes. Class student will represent one student, and course stores a list of student objects. The course methods will manage that list. The main idea here is that the course object owns the behavior for managing its students. Adding, listing, and searching our course responsibilities. So we'll define our classes, class student, and we'll give it a constructor init, pass it self, and name of the student, and self.name is equal to name. And then we'll have a wrapper self, and we'll just return f student name is equal to self.name exclamation point r right there. And we'll have a class called course. And we'll also create a constructor here, def init, self title. And in here, we'll have self.title is equal to title. And self.students is equal to just an empty list for right now. And it'll store a list of student objects. And here, we'll have add student, which takes in self and a student instance. Notice how we're passing in the instance here, and here we can do self.students, and we can append to our list an instance of student. And here we'll define a method called roster, and what we'll do here is return a list of student names for display. So we'll have names is equal to an empty list here, and then for s in self.students, we're going to iterate over this list and return a list of student names. Names.append s.name, and we'll return the list of names. And here we've implemented a method to get the roster of students, and then we'll also have a find student method right here, which will take in a self and name. And what this will do right here is it's going to search, and it's going to search for that specific student. And we also want to make sure we catch all the students regardless of capitalization. So we're going to make sure it's case insensitive. So let's get target is equal to name.strip.lower. And now we have our clean name right here. And then we're going to iterate through self.student. And if s.name.lower is equal to the target name, then we return that instance. And if we find nothing, we'll just return none. Now let's jump into our actual script here. Course is equal to a course object called Python 101. And we can have add student, and again we'll have a student object for myself. Do the same thing for Madison, and then we can print the course dot title, and then print course dot roster. We can also see if we find a student. So found is course dot find student. Oops. So we're interested in finding myself, and we know that this should return the student object right here. And we'll also have a missing with the same premise, except it's going to be for a name that doesn't exist. We know that Kevin does not exist. We know that Calvin exists, but not Kevin. And then we can run this. Whoops. We have a typo right here. Now, we can see that we get the correct prints. Again, the main summary here is that we have students, but course will do basically all the management of the student objects here. That's the thing to remember here. A lot of code will be structured in this way. And those were the concepts that I wanted to cover in part 2 of object-oriented programming. As usual, we'll do our git workflow, git add, lecture 11. Oops, not lecture. Git add, lesson 11. Git commit, lecture 11, object-oriented programming, part 2. And we'll push this. And we'll successfully push to the course repository and save our progress. And that's it for this video. If you liked the video, be sure to like, comment, and subscribe. And be sure to check out my book, Modern Data, From Ingestion to Production. I'll see you guys in the next video, where I'll cover inheritance. Thanks for watching.